Hi and welcome to EIGRP, Enhanced Interior Gateway Protocol. EIGRP was originally a Cisco proprietary protocol for all intents and purposes. It's still a Cisco protocol, but let's take a look inside and see what we can find out about it. In 1992, as I mentioned, this was a proprietary protocol, and now we have it's open standard, and it's an advanced distance vector routing protocol. Unlike it's a lot like OSPF. It's Cisco's answer to OSPF. It uses a different setup as far as the algorithm. It's called dual or diffusing update to calculate paths and backups, but like OSPF, it establishes neighbor adjacencies, uses a different name protocol. It uses RTP, or Reliable Transport Protocol, to carry the information out to the routers. A couple of terms, we say they are partial and bounded, and we'll talk about that in a minute, but that means they only go where they need to go and only send what they need to send. One thing about EIGRP, it uses protocol-dependent modules. PDMs, what that means is it has a different module and different function for every protocol that it comes into. For example, IPv4 and IPv6, it creates a different table for each one. That's the protocol independent, meaning that it develops a separate routing process for each one. It doesn't put them all in one. And so you can see here in this diagram, RTP is what's going on, but it still has a neighbor table, a topology table, and a routing table for all three of these. It'll have it for IPv6, IPv4, different connections. EIGRP, like OSPF, can handle authentication. So they're just it's very similar to OSPF because that's what it was designed to be. The OSPF is, it has different packet types. It has hello packets, update packets, query packets, and reply packets. In this sense as well, it's not very different. Of course, I had to change some names, but a lot of the things still happen. So the same as in OSPF. So the hello packets, they're sent out multicast in different addresses for IPv4 and IPv6, as you can see. The hello packets maintain neighbor adjacencies. The neighbor relationship stays up, and they go every 5 seconds, okay, unless it's 60 seconds for a slow, non-broadcast multi-access network. And EIGRP has default hold times. Remember, there's the hold time of 3 times the hello interval. So whatever you set the hello interval to, then you'll have the default hold timer will declare it unreachable after 3 times the hold timer value. So update packets are sent to propagate routing only when necessary. That's what's meant by partial and bounded. Means only the updates information that has changed gets sent out, and bounded means it only goes to the routers that are affected by the change. So it's that limits traffic and limits processing on some of the machines around. So if it's got limited scope, very few routers and very little information has to be updated. Those updates, by the way, are reliable delivery, so they are acknowledged. Now, when looking for new networks, when it's setting up, discovering its neighbors, etc., it sends out queries, and the queries use reliable delivery in multicast or unicast, so they need replies as well when they send those out. And this is just a quick picture of an EIGRP message. You'll see this online in a little bit better form, but you can see it still has the data link frame header, then the IP packet header, and then an EIGRP header with its type of EIGRP, for which protocol, packet type, the autonomous system number, etc. And then the TLV types, time to live, values, okay, different parameters in EIGRP. And that's what the header looks like. So, with the flag sequences, acknowledgments, etc. Wireshark is a pretty good place to do some of this looking around. I'm going to pause right here because otherwise these get a little bit too long. We'll talk about the operation of EIGRP in the next section.